Part of it might have to do with how they reproduced. Paraceratherium was a placental mammal like us, and if this ancient rhino was anything like large mammals we have alive today, that would have taken a very long time. Big mammals like giraffes, rhinos, and elephants usually only have one offspring at a time, and gestation can last longer than some other kinds of animals live. Elephants, for example, carry their babies for more than 2 years. Now consider the dinosaurs. They didn't really have to carry their babies at all because all the dinosaurs laid eggs. Even the biggest of the giant dinos hatched from an egg no bigger than a soccer ball. What does this have to do with size? Well, bigger mammal species give birth to bigger young, which requires a huge amount of time and energy to gestate. Dinosaurs totally bypassed that problem. Instead of having bigger babies, the largest dinosaurs laid comparatively small eggs, which held equally small hatchlings. Reproducing this way, with babies hatching and growing outside of the mother's body, removed the size limit that gestation places on mammals. Dinosaurs also had another evolutionary advantage. Their skeletons had a special feature that mammals lacked: a sophisticated system of air sacs. These sacs were basically pockets of soft tissue that were connected to the lungs. Think of them as biological balloons. Some of these sacs sat in the body cavity next to bones, usually in the neck, back, and hips, but others ran inside the bones themselves. These air sacs helped shape the dinosaur's skeleton and allowed the bones of the biggest dinosaurs to remain light without sacrificing strength. How do we know that extinct dinosaurs had these sacs? Partly because the non-extinct dinosaurs have them too. Birds have a similar system of sacs that help draw air into their tiny lungs while also making their skeletons remarkably light. And if you compare the respiratory system of birds to those of the giant dinos, you'll see the resemblance is pretty striking. In sauropods, for example, the vertebrae of the back and neck have the same pockets and divots we find in birds today, where these air sacs were attached. And when paleontologists scan fossils of some dinosaur bones, like vertebra, they often find hollow spaces inside the bones. Now keep in mind that bones with spaces created by air sacs are different from the hollow bones that you see in the legs of birds and other theropod dinosaurs. And not all of the extinct dinosaurs had these handy airbags. Only the type of dinos known as saurischians had them. In the traditional dinosaur family tree, this group encompasses the theropods, that is the two-legged dinosaurs that include today's birds, as well as the sauropods, the quadrupeds that include the giant titanosaurs. All of the rest of the dinosaurs, like the horned, armored, and duck-billed dinosaurs, are known as ornithischians, and they didn't have these features, so they weren't as light on their feet. And of course, we mammals don't have anything like them either. We retained a skeletal system of dense, heavy bones that puts a limit on how big we can get before our bones crack under our own weight. But the thing is, these adaptations are just what allowed dinosaurs to get so big.